Good afternoon. Well, welcome back to our final plenary session for this symposium. Hopefully everyone is sated physically, and now we can get back to the business of getting sated intellectually. One of the main themes that we're addressing in the symposium, as articulated yesterday by Dr. Cliff Kane, concerns the intersection between religion and science. And it's an honor for me, of course, to introduce to you our next speaker, Dr. Eugenie Scott, who will discuss this intersection. In today's culture, the relationship between religion and science is perhaps no more poignant than the relationship between biological evolution and creationism. Now, the aim of both of these areas is to explain not just our own history, but the history of the diversity of life on Earth. As such, I think they demand some sort of reconciliation. And Dr. Scott will help us think more critically about this issue, and particularly more broadly the relationship between science and religion. I think few are better qualified. Dr. Scott has been a researcher, educator, consultant, activist in the creation evolution controversy for over 25 years. She can address the educational, legal, scientific, religious, and social issues that intersect with this controversy. Currently, she is the executive director for the National Center for Science Education, a role she has served since 1987. She is the fellow of the American Association for the Advancement of Science, author or co-editor of 2 books on the topic of evolution and creationism. Her work has earned her 8 honorary degrees and such prestigious awards as the 2009 Stephen Jay Gould Prize, the 2010 Public Welfare Medal awarded by the National Academy of Science, and the 2012 Richard Dawkins Award. And I must admit a little bit of jealousy and delight when I learned that she also published a paper in one of my favorite journals, the Annals of Improbable Research, also known as AIR for short. Now, not only has she published in this journal, but her paper is cited as one of the classics. Now, if you're not familiar with AIR, their goal is, I quote, to make people laugh, then to make them think. And articles published in AIR, they present original, real, scientific research that answers perhaps some of the most vexing questions of our time. For example, whether or not most exotic meats do in fact taste like chicken. Whether or not it does rain more on the weekends, and even a scientific comparison between apples and oranges. Dr. Scott and her co-authors looked at the morphology of scientists named Steve. And if you're curious why they would do such a thing, I encourage you to check out the NCSE's Project Steve. I'll leave it at that. But more seriously, the reason I bring this up, I think it highlights something else that Dr. Scott is known for. In addition to her awards, in addition to her accomplishments and her contributions, she's also known for just her charming, lighthearted, unassuming personality. So it is my pleasure. Please join me in welcoming Dr. Eugenie Scott.
Well, that spoils that I can't be crabby now since he's... Happy talk like a pirate, Dave. You've had a very interesting series of lectures yesterday and today. The symposium organizers are to be congratulated in assembling a very interesting group of speakers and topics. Now, science, origin, and religion is a big topic, and I'm not going to exhaust it in the 4 hours that we have this afternoon. I'm going to try to address all 3 of these topics, how they are similar, how they are different, how they interrelate. But first of all, I want to provide an example for why it's necessary to have a better understanding of the relationship of science and religion. A Facebook post I received this morning, and yes, the old lady's on Facebook. If you want to friend me, please friend me at eugenie.scott. This is actually where I update as opposed to all those other Eugenie Scott sites where I don't update. I had told my Facebook friends I was in Fulton for a talk, and a comment read, here I am embarrassing my hosts in the biology department, Westminster is my BA alma mater. Cool that you are there, especially since I remember being denied learning about evolution in biology class there in my freshman year by a loudly objecting student who didn't believe it and intimidated the prof into not teaching us about it. I hope things have changed in their biology program since then. They have changed, and the biology program since then. Okay, so science and religion is still important. But first, before I get into the specifics, I want to talk a little bit about what our beloved philosophers of science call epistemology, ways of knowing. Now, knowledge in the sense of ways of knowing doesn't necessarily imply accurate knowledge, okay? Because we all have knowledge that's just wrong. Some knowledge people hold as erroneous. Epistemology looks at the structure rather than the content of knowledge. And I want to talk about 3 ways of knowing that are relevant to thinking about the topic of my talk. I want to talk about science, I want to talk about insight, and I want to talk about authority. And I'm going to start with insight. Now, insight is defined as knowing through internal or personal states of being. This would include intuition, meditation. It might even include aesthetics. There are many ways of generating these internal states. The Yanomamo Indians of the Brazilian rainforest take a hallucinogenic snuff, which they blow into each other's nostrils. Hurts like hell. But it does have the requisite effect that they seek, which is to give them hallucinations, which they interpret as the spirits of the forest entering into their bodies and giving them wisdom. There are, of course, more familiar examples, including Woodstock, where various substances have been used to create knowledge, or at least the thought of knowledge. Internal states of being, insight, etc. We've all had situations where we've just known the answer to something, whether we were right or wrong, of course. We feel we're correct. And we can't attribute it to anything other than a gut feeling. And you may be very certain of the truth of this gut feeling. Yet, such experiences are not persuasive outside of the cultural context in which they occur. Christians who are slain in the spirit will not find believable the Yanomamo claim of being possessed by spirits of the forest. Neither will the Yanomamo accept the Christian view of being inhabited by God. And my gut feeling is not necessarily your gut feeling. The subjectivity of personal states of being make this way of knowing unreliable and also limits its utility in persuading someone else of your experience. If you haven't had the feeling of being touched by God, claims of it are not likely to resonate. There's no universal ways of confirming these claims. Let's take a look at authority. Now, I come from California, where there's a bumper sticker that's very popular, question authority. I always get this great urge to grab a magic marker, and when I see one of these bumper stickers write, question authority, but stop at stop signs. I mean, authority in and of itself is not necessarily negative, right? Now, parents and other adults are our first authorities, and children learn to accept their proclamations. A large fat man comes down the chimney at Christmas time, and this is accepted by small children on the authority of their parents until what time that is no longer accepted based on the experience of the children. On the other hand, there's a certain adaptive value for children to accept the authority of parents. Don't tease the saber-tooth was probably highly adapted for those children in the Pleistocene. They probably tended to survive longer and pass on their genes longer than those who didn't. And don't play in the traffic is instilled in children before they can understand the empirical dangers of this behavior. So, authority in itself is not all that bad. We accept authority in most things, I would suggest. I don't know very much about particle physics. I don't know anything about particle physics. And I will tend to accept the Nobel laureate Steve Weinberg's proclamations about particle physics when he talks about quarks. Now, a little bit later on, I'll talk about how there's a subtle difference between the kind of authority I'm talking about in terms of, don't tease the saber-tooth, and the authority that we may grant to somebody like Steve Weinberg in talking about science, because they're different in a significant way, but I'll come back to that. Now, there's a particular kind of authority, which is known to many religions, called revelation, when knowledge comes from sources considered sacred. The ancient Greeks accepted the authority of the oracle at Delphi because they believed that the god Apollo spoke through her and gave her truths. Islamists believe the Quran was revealed to Muhammad. Jews and Christians believe the first books of the Bible revealed to Moses. Catholics and Mormons believe the heads of their churches, the Pope and the President respectively, receive revelations from God. Revelation requires belief in supernatural powers, whether Apollo, the ancient Norse god Thor. It's got to be the corniest picture of Thor, nonetheless. It could be ancestor spirits in some tribal societies. It could be gods, or it could be God. Truth is considered revealed from these sacred sources. The Bible is considered a book of revealed truth, at least in part, by most Christians. Now, mystical personal states of being often are combined with revelation. Apollo's oracle at Delphi would go into a drug-induced trance to receive the revelations. So revelations, in many respects, has some of the same shortcomings as knowledge acquired from personal experience, from internal states of being. It's culturally conditioned, and being based upon subjective experience, it's impossible to verify by an outsider. Catholics don't believe the Mormon president is spoken to by God. Mormons don't believe that God speaks to the Pope. Revelation, on the other hand, can be a way of knowing that has great power with people. The Krishna Consciousness Movement, which is sponsored by the Bhaktivedanta Institute out in California, interpret the Vedas, the sacred books of the Hindus, as requiring that the sun is actually closer to the earth than is the moon. As a result, they believe the moon landing is a hoax. Here is a piece from their website. I'll blow it up for you so you can not go blind reading it. We have information from a very reliable source, the Sanskrit Vedic scriptures, that the so-called astronauts never actually went to the moon. The manned moon landing is actually a colossal hoax. This is a revelation. They accept the revealed truth, their interpretation of the revealed truth of the Vedas. Now, as with knowledge obtained by internal states, knowledge obtained by authority is not always easily transferred. Why do you accept the popular version of the manned moon landing? Because you believe the authority of the scientists, the journalists, and the politicians who propagate that version. When we cite the Vedic scriptures, which state that the astronauts could not have gone to the moon, we're simply favoring another authority. In both cases, it's a matter of accepting an authority and believing what it says. Few people in this room, I suspect, accept the authority of the Vedic scriptures when it comes to the positions of components of the solar system. Most of us accept that the sun is farther away from the earth than the moon. Yet note that the Krishnas believe that one authority is as good as another. Now, I suspect most of us accept the moon landing on authority, but we don't have to. I suggest that the authority of science is qualitatively different from revealed authority, such as the Vedas. So let's talk a little bit about science. Now, I'm willing to say that science is authoritative, but it's not authoritarian. There's a difference. Despite the Bhaktivedanta's belief about us just willy-nilly accepting the authority of scientists, the authority of a scientific pronouncement is rather different from that of one from revealed truth. I might choose to accept Steve Weinberg on quarks, but I don't have to accept his authority. Weinberg didn't come to his conclusions about quarks because of a dream he had or because someone revealed the nature of quarks to him. Regardless of what the non sequitur comic strip said yesterday, if you follow this comic strip, it's really, they had a comic strip yesterday that was so on point I had to include it in my talk today. Hey Lars, can we have a talk about this God particle thingy? No, and stop calling it to that. It's the Higgs boson. Okay, so what's such a big deal? Well, Lars is this little extraterrestrial who lives in the sewer. He lives in the sewer. I guess you can't read that very well. It's kind of a small thing. And anyway, Lars comes out in his little spaceship and he says, because the power it can generate is too dangerous. He says, and every time we've given you talking monkeys something good, you pack it into something destructive. This is about the internet, isn't it? Okay. I don't think any of us really believe that the Higgs boson was discovered because an astronaut, or because a little extraterrestrial told the scientists in France, in Switzerland, about the major secret. We laugh because we know how much work it was to find the Higgs, and that it wasn't revealed by extraterrestrials. That's the easy way. The people who found the Higgs particle, and Steve Weinberg with quarks, followed a process which you or I could follow, which is why science is a different kind of authority than the authority that you accept based upon revealed truths. I'm saying this in something of a hypothetical sense in my own case, because it would take me several years to learn the math, but I could do it, okay? There's a repeatability and an independence about the process of science that doesn't occur with knowledge obtained from authoritarian or internal states. So let's talk a little bit about what science is. Now, science is a body of knowledge about the natural world, but more importantly, it's a way of knowing. It's an epistemology, it's a method. It's a limited way of knowing. In science, we're trying to explain the natural world using natural processes. We limit ourselves to trying to explain only the natural world. Lots of things human beings are interested in that are other than the natural world. I mean, I couldn't prove to you that Mozart is better than Green Day or Green Day is better than Mozart using science, okay? That's not a scientific question. But if you're dealing with the natural world, if you're dealing with the world of matter and energy, that's what science is trying to explain. And we limit ourselves to answer questions that we might have using natural processes. And there's a very good reason why we restrict ourselves to natural processes, which I will get to in a moment. So what is the scientific method? Well, scientists and science educators often express frustration with lessons on the scientific method as if it's a recipe. Ask a question, formulate a hypothesis, perform the experiment, collect the data, rinse and repeat. This is 7th grade science. It's generally true, but it's too simple. Science is much more like a web of factors than a linear procedure. Now, what I want to talk about is how testing, that big green circle there, testing is really at the heart of what science is all about. And it's what makes science as a way of knowing different from the others that I've been talking about. This is from the wonderful Museum of Paleontology at the University of California, Understanding Science site, if you want more information on that. Notice I'm talking about testing, not experimenting. The word, now an experiment is a kind of test, clearly, but the word experiment has a particular connotation of something done in a laboratory. And obviously, experiments aren't always done in laboratories. Experiments can be done in field settings. The connotation of experiment is kind of narrow, so I talk about testing scientific explanations. I think it gets rid of that baggage, so to speak. And the essence of testing is controlling certain variables so that you can see whether the explanation you have is really the likely to be the most accurate one. There are lots of ways of controlling variables. You can control variables directly, as in most of what most people think is an experiment. You can control variables statistically, observationally, in a computer simulation. There are many different research designs, which if you go into science, you will learn about different research designs. Unfortunately, our fellow citizens don't have a very clear idea of the process of science. Now, the National Science and Engineering Indicators is a survey that's conducted every 2 years by the National Research Council, and these are very interesting books. That's just as a cover from '04, but there was also one in 2012. They talk about knowledge of science. You're familiar with this? You've probably heard the statistic that only 53% of our fellow citizens understand that the planets go around the sun and it takes a year to do it. That's these guys, that's this thing. Okay, they also ask the respondents to explain in their own words, what is science? And the correct answer is, testing of explanations or some sort of systematic comparisons, at least experimentation, something like that. Only 1/3 of Americans had close to a correct explanation of what science is. Most of them thought it had something to do with just piling up lots and lots of data, which really isn't how science is done. So the good folks at the National Research Council thought, well, okay, if they can't recall it, let's give them an example and see if they can figure it out. So they had this really great example, which is testing a blood pressure medicine. One possibility. You've got a blood pressure medicine, you want to know if it works. Do you find 1,000 people with high blood pressure and give them all the drug and then come back later and see whose blood pressure goes down? Or do you find 1,000 people with high blood pressure, give the drug to 500 people, don't give the drug to the other 500 people, and then come back later and see who has lower blood pressure? Okay, boys and girls, how many think it's number 1? Raise your hand. How many think it's number 2? You did better than most of your fellow citizens. That 46% is the highest our fellow citizens were able to achieve on this. Okay? So the idea of controlling for variables, the idea of testing scientific explanations is something that we have not done a very good job communicating, we being teachers and college professors, this is you, have not done a very good job communicating the basics to the general public. And yet, figuring out how to test a claim is actually one of the most challenging intellectual experiences one can have. And it's really the essence of critical thinking, whether within a scientific context or not. These people belong to a dowsing society in England. They claim that they can find water with a forked stick. Now, the claim is that a mystical force, well, that's actually 2 claims, that they can find water with a forked stick, and that there's a mystical force that goes through the dowsing rod that when they get close to water or precious metals or some people claim they can douse over a map and find lost objects and bodies and lost children and whatever. But there's a mystical force that draws the point of the dowsing rod down toward the water. Okay, do you believe them? Or are you from Missouri? Well, a scientist would say, okay, that's your claim, your 2 claims. How can we test this? Now, it's possible that you can find water with a forked stick. How many think it's possible these people will find water with a forked stick? You can't miss. You know, the only way they would not find water is if they were blindfolded and had thick boots on and weren't walking. There's water all over the place, all right? This is one of the main features of pseudoscience, that whenever you hear about a psychic detective, the psychic detective said the baby will be found by water. Well, duh. If it's found near, there's water all over the place. If you find, if the body is found near a sewer line, I get a hit. I said the baby would be found near water. This is like saying the body would be found near oxygen, right? Sometimes you just can't miss. Okay, so it's very likely that these dowsers will find water. What a scientist, or you critical thinkers might thereupon ask is, so you claim that there is a mystical force that is drawing the point of the dowsing rod toward the water. Is there another explanation, like the fact that there's water all over the place? Asking the question, is there another explanation, is really what science is all about. It's that questioning about, well, is there a better explanation than the one that I've just been given? And how do we test it? That's really what science is about. There's a lot of fun you can have if you go to the Australian Skeptics website. And because they have all kinds of films about tests that they have done in Australian dowsers. The dowsers all agreed to the protocol. They agreed that they could find if you look here, you see these little white these are white bags. Some of them have water, some of them do not, but they're covered up so you can't tell just by looking. And the dowsers all were convinced that they could find the water in the bags as opposed to the waters that just had sand in them. So, and under controlled conditions and greater than expected by chance. I mean, obviously, if you have 10 bags, 9 of them have water, the chance is really good that a dowser is going to find water, right? So you have to sort of set it up to eliminate probability. And you also have to do a number of other things, like make sure that none of the dowsers know where the water is. Okay, they have to be blind in the sense of the variable that you're trying to collect information on, which is that they can actually find water. And the guy with the clipboard who's writing down which of the bags the dowsers claim has water, that guy also can't know which bags have water, right? Because he might inadvertently cue the dowser. It's called double blinding. When neither the experimental subject nor the investigator knows what the right answer is. And double blinding is the sine qua non of a good scientific test. It's why so much of the scientific research on vitamins and other kinds of alternative health therapies have been rejected by the scientific community, is because they're not double-blinded. And people expect to get better when they're taking, 500 milligrams of selenium or something, whatever the hell. If they expect to get better, they're going to get better. So you have to double-blind this study. That is what science is all about. Now, most scientific tests are a combination of testing and inference. Now, in this is a direct experiment, and you find out right away that, in fact, if you go to the website and you look at their studies, you find that the dowsers did no better than expected by chance. Under controlled circumstances, dowsing disappears. They can't even find the water, much less that there's a mystical force. But most really good science, most of the really interesting science, goes beyond the just sort of direct experimental observation like this. And it requires inference, requires taking the tested hypotheses, so to speak, and inferring from them some conclusion that you use to generate additional questions about the natural world. Ken Ham is a young earth creationist. He runs Answers in Genesis. And he's very fond of saying, "Were you there?" as a refutation of evolution. Well, no, I wasn't there, but I have very good information that points to the inference that living things had common ancestors, which is why we accept evolution. Ken Ham and a lot of Americans believe that direct observation is the only kind of real science, that any kind of inferential science is a second-class science. It's really not a kind of science that is valuable. I'd love to talk more about the importance of inference. I don't have the time. We only have 4 hours this afternoon. But I do want to warn you about the perils of direct observation. There's this tendency that we have to think that direct observation is really highly valid, highly accurate. Not necessarily so.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
Sorry, madam.
It's just a matter of observation. The real question is, how observant were you?
And action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Service announcement by the BBC about watch out for bicycles, but it was just so perfect about how direct observation is not necessarily the most accurate way of collecting information. Inference is very important. Let's look at the scene of a highway as a better way to understand inference. Were you there? No. but we can infer what happens. There's various substances here that you can see. Now, the road is on the bottom. The cow pie is next on the road. Next is the highway department stripe. Next is more cow pie. And finally, tire tracks. Now, we can infer what happened, even if nobody was there to watch the particular sequence of events that resulted in this rather odd series of events. How many think the tire tracks were laid down first? Of course not. That's illogical, isn't it? So we can use logic. We know that stuff on the bottom is first, right? So clearly the road had to be there first before the tire tracks. So logical things like that would help us infer an explanation for what happened here. The inference that I think is safe to make is that the highway maintenance crew was lazy. They didn't bother to scrape the cow pie off the road, but just went ahead and striped over it. And then a car came along a little bit later on and mushed the cow pie on top of the stripe, and then et cetera, et cetera. So, you know, is there another explanation? I'm always asking people to ask, is there another explanation? Well, we could perhaps come up with other explanations. We might infer perhaps that an astronaut from outer space came in and built this construction precisely as we see it, but that's not terribly probable. We all have had plenty of experience with lazy maintenance crews and very little experience with Martians. So, you know, the sequence of stripe, cow pie, more cow pie, tire tracks is much easier to explain. You take the most straightforward and logical explanation, but nobody was there to see it happen. This is an inference. But I think we can be pretty confident that our inferential explanation is likely to be true. All right, what about religion? Now, religion is not an epistemology in my definition. It's not a way of knowing. It may be a way of life. It may be an ideology that permeates an individual's consciousness and everyday activities and gives life meaning. It may structure every relationship an individual has with an animate or inanimate universe. Muslims often speak this way. It can be extraordinarily important, but it is not an epistemology. It is not a way of knowing. Actually, religion draws from all of the ways of knowing that I've presented here. It draws from authority, especially the authority of revelation. It draws from personal states of being or insight, and many religions are informed by science. So let's talk a little bit about religion. Now, as an anthropologist, I find that looking at religion through my eyes is a little bit different from that of most Americans. I think when most Americans think of religion, they think of Christianity, and primarily of their own version of Christianity. More educated people might reflect on the great Middle Eastern monotheisms, Christianity, Judaism, and Islam. Still more sophisticated individuals might think of religion as including these institutions, but also other world religions like Buddhism, Confucianism, Hinduism, Taoism, and so forth. But anthropologists understand religion as a phenomenon that occurs in these world religions, but also among people who no longer exist. Nobody's praying to Zeus these days. And among a very large number of small groups of people who have distinct religions about which we know very little. Native Americans can be roughly divided into 5 different culture areas, at least at the time of contact, where cultural traditions are similar but not identical. Religious beliefs within a culture area also are similar but not identical. The Pueblo Indians of the Southwest, for example, exhibit many different tribes and also tribal religions. The Hopi and Zuni religious beliefs differ in significant ways, and their neighbors, the Navajo, comparatively recent migrants to the area, come from a completely different culture area and have quite different religious beliefs. There's no such thing as Indian culture. There's no such thing as Indian religion. It's very varied. Although Christianity and Islam have made major inroads in Africa, there still is a great deal of the continent where tribal religions occur, sometimes often, usually, incorporating elements of Christianity. And let's not forget other parts of the world like Melanesia, where over 700 languages are spoken, and the variety of religions is probably comparable. So religion to me is much broader than Christianity. How do you come up with a definition of religion that fits all of these human experiences? It's not easy. As an anthropologist, I define religion as a set of rules and beliefs that people have about a non-material universe and its inhabitants. By a material universe, I mean this material matter and energy universe that you and I are living in at this moment. Most human beings, most human cultures have a concept of something beyond this world, material world in which we find ourselves. And this other universe, if you will, has inhabitants. They are gods or the ancestors or something. But there is in some way a way of interacting with these supernatural forces. Religions usually have concepts of an afterlife, but not always. Not all religious views have a concept of life after death. And most religions have ideas about ethics and morals, but not always. Sometimes in societies, ethics and morals are determined not by supernatural forces, not by the gods or gods, a god, but by custom. We do it this way because that's the right way to do it. So there's a lot of variations out there with religion. Similarly, many religions have explanations of the natural world, but not all of them. And virtually all religions have some sense of the spiritual, as this is expressed in awe or wonder or reverence, faith, and other emotions. Now, religion contrasts with another philosophical view called materialism. Now, religion, as I define it, requires a supernatural component. Materialism denies the supernatural or considers it irrelevant. This statement by Richard Dawkins is a classic statement of materialism. The universe as we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil and no good, nothing but blind, pitiless indifference. It's not an especially new view and can be traced in Western culture, at least as far as some of the Greek philosophers. In my opinion, there probably was some Pleistocene Homo sapiens who didn't really swallow the stuff about the gods guiding them to the hunt if they only fasted the night before, but he generally kept it to himself so he wouldn't be put out on an anthill someplace. And there certainly are plenty of places in the world today where a non-believer can get you killed. Personally, I'm rather glad I'm living in the United States in the 21st century. So materialism is a non-supernatural philosophy. Now, is materialism the same as science? No. I mentioned before that science explains through natural causes. Obviously, materialists believe that natural causes are all there are. That's not the same thing as science. Science is methodologically materialistic in that we restrict ourselves to matter and energy explanations. That does not mean that science per se, nor certainly scientists, are philosophically materialist. Look at it this way. Certainly it's reasonable that if you are a philosophical materialist, you are also a methodological materialist, because philosophical materialists don't believe in the supernatural, of course. They explain the natural world through natural causes. Those are the only ones they believe operate in the universe. So as the diagram showed, all P's are in. But that's not the same thing as saying that all methodological materialists have to be philosophical materialists. And in fact, there are approximately 1/3 of scientists who are methodological materialists, but who also believe in God or a higher power. There's a lot of confusion between science, materialism, and religion, so I'd like to talk about the differences and similarities a little bit more. If we look at religion, does religion use logic and empirical evidence? Yes. Does it use revelation? Yes. Are mystical personal states of knowing important? Yes. How about in science? Logical empirical evidence used? Yes. Revelation? No. Personal mystical states of knowing? No, because we got to test stuff. We may wake up with a dream of a snake chasing its tail and decide that we're going to discover, run some tests to figure out what benzene rings are, but we got to run the tests. I mean, you're not just going to publish the article. I know how benzene rings are formed. You got to actually do the work. So dreams, gut hunches, and so forth. That's not how we do science. Similarly, how about if we take a look at materialism and compare that on these same qualities? Logical, empirical evidence, yes. Revelation, no. Mystical, personal states of being, well, hard to tell, really. Most materialists are not supernaturalists. That doesn't mean that some of them might not accept gut feelings or other kinds of mystical behavior. Not being supernatural doesn't mean you can't be mystical, if that makes sense. And it does, actually, if you think about it. How about religion looking at supernatural powers? Yes. Belief in a non-material world? Yes. Spiritual beings? Of course. Science? Supernatural powers intervene? Well, we just have to kind of assume that they don't. Think about that. There's a difference between saying there is no God and assuming that he's not going to screw up your experiment. Okay? The nature of science is to try to figure out the regularities, the theories and laws that govern the operation of the natural world. If those can change tomorrow, because we've got a whimsical God who just decides that water's not going to be H2O tomorrow, it's going to be something else, then it'd be really difficult to do science or live, actually. So scientists have to assume, at least for the purpose of doing science, that God is not there messing around with the, God is staying out of your test tube, so to speak. Belief in a non-material world, science has no opinion. All science can deal with is the material world. So science as science can't make any statements about whether there is or is not a non-material world. It's outside of our purveyance. Belief in spiritual beings, similarly. It's just not part of the job description of science. Remember I said science is a limited way of knowing? Methodological materialism means you're stuck with using natural causes, because natural causes are the only kind you can test. We have no theometer. There's no way for us to test for the actions of an omnipotent power, and there's no way we can hold constant the efforts of an omnipotent power. God is unconstrained. If there is a super powerful being in the universe, there's no possible way you can hold constant to its effects. So you have to just leave it out if you're going to be doing science, regardless of whatever your personal opinion is. How about materialism? Supernatural powers intervene, materialists say no. A non-material world, materialists say no. Spiritual beings, materialists say no. Let's look at some other qualities. Belief in an afterlife, most religions. Concern with ethics, morals, yes, most religions. Sense of awe, mystery, sacred, yes, most religions. Science, belief in an afterlife, not as science. I mean, as individual scientists, we may or may not, but science can't prove there is or is not an afterlife. It's a non-material phenomenon. Concerned with evil, ethics, morals, science isn't concerned with that. Is it immoral for a coyote to kill sheep? Well, no, that's a dumb question. That's not the kind of question that you would ask in science. Scientists may be very concerned with morals and ethics, but science itself, that's not part of the job description. A sense of awe, mystery, again, as science doesn't really have an opinion on it. Materialism, on the other hand, no afterlife. Yes, materialists are concerned with evil's ethics, or with evil ethics, morals, these kinds of human rules and so forth, especially humanists. A sense of awe, mystery, the sacred. Yes, but it comes from nature, not from supernatural sources. So, this is almost impossible to read, especially since it's not very big, but hang in there with me. Let's look at science, religion, and materialism and see how they compare. In terms of similarities, science and religion share, is it here? There we go. Science and religion share one similarity. They both can use logic, and religion can use logic. And religion is not an illogical, at least, theology that means anything is, it involves logic. On the other hand, science and materialism, science and materialism also share one similarity, and that is, again, logic. Religion and materialism, on the other hand, share three similar components: logic, ethics, and awe. Notice also that materialism and religion share, science and religion came up next. You'll be able to look at this at your leisure anyway. My notes are crazy. Science and religion share two dissimilar qualities: revelation and the concept of a using mystical sources of knowledge. But where you really get the difference is between materialism and religion. Now, the greatest similarities and the greatest differences are between religion and materialism, not between religion and science, right? And that's because materialism and religion are both ideologies. Science is a way of knowing. Science is an epistemology. It's a different category of thought than our ideologies, like materialism and religion. So my suggestion is that the disagreement between science and religion is misplaced. It should be between religion and materialism, not between religion and science. If you really understand science as a methodologically materialist in a human endeavor, as opposed to an atheistically inclined endeavor, which is sort of like saying, scientists like Mozart, or they don't like Mozart. It's irrelevant to the actual doing of science. Let me try to express this in another way, because there's been a great deal of discussion, shall we say, noise is another noun, on the internet and in books and so forth, about whether science is inherently atheistic, whether in order to be a proper scientist you have to be an atheist. Now, I'm down there with the materialists, okay? Full disclosure here, it's not a surprise. I don't hide it. The creationists have a tough time with my being a pleasant person but still a materialist. I don't appear to be an axe murderer, but nonetheless, I'm a materialist. Nonetheless, I'm down there with the materialists, but I don't believe that science compels an atheistic philosophical stance. Let me try to illustrate this in another way. Visualize a garden. Okay? Now, the flowers are in competition with each other. The flowers are competing for water, for sunlight, for nutrients, and so forth and so on. Let's say that instead of this being an actual botanical garden, this is an ideological garden. Okay? And we have theistic views and non-theistic views. Now, the theistic views are in competition with each other. The Catholics and the Protestants and the Hindus and the Muslims and everybody else. This is sounding like a little bit like an old song that some of us of my generation remember. National Brotherhood Week, but never mind that. But anyway, they're competing with each other, and they're also in competition with the non-theistic views. Okay? Now, both theistic religions and non-theistic religions claim to be inspired by science. Okay? With is methodologically naturalistic, again, not philosophically naturalistic. Science per se is not a philosophy of life. It is a method, it's a way of knowing. The plants are in competition with one another. They're not in competition with the soil. Okay? That's the difference here. Science nourishes both theistic and non-theistic views. Science is not in competition with religion, non-theistic views like atheism, agnosticism, and humanism are not in competition with theistic views for science, because both of these ideologies, both of these groups of ideologies, accept science, many of them, and use science to inform them. I would suggest that theist-atheist ideological competition should be viewed as being between competing worldviews. Neither religion nor atheism owns science. But wait, there's more. Just as soil is underlined by bedrock, which nourishes the soil in various ways, critical thinking underlies science. But critical thinking also underlies other intellectual pursuits in addition to science. Art, literature, history, all of these other human endeavors, shall we say, depend upon critical thinking if they are to be proper scholarly activities, valuable and valid scholarly activities. Science doesn't own critical thinking. Critical thinking is an equal opportunity bedrock for lots of intellectual endeavors, just as science is an equal opportunity soil, shall we say, for theistic and non-theistic views. So, in my opinion, we can encourage everyone, regardless of their ideology, to be a critical thinker and to accept and appreciate science. Personally, I think we'd all be a whole lot better off if we did. Okay, I'm also supposed to talk about origins. I'm going to have to go fast because we only have 2 more hours left. So how does the idea of origins come into this? Well, first of all, what is evolution? Evolution is a general principle that cuts across all of science, that the universe has had a history. The past is different from the present, that there's been cumulative change through time in the universe. So astronomy is an evolutionary science, and geology is an evolutionary science. Biology and anthropology are also evolutionary sciences. There has been cumulative change in all of these disciplines. In the case of biological evolution, we're talking specifically about the idea of living things having common ancestors. And biological evolution is a 3-part idea. The big idea of biological evolution is common ancestry, that living things have descended with modification from common ancestors. And that is the big idea, the idea that scientists agree upon. The processes or mechanisms of evolution, including natural selection, various non-selective means, other mechanisms of evolution, speciation, et cetera, these are areas in which scientists have vigorous debates about how important is natural selection versus other mechanisms, on and on and on. That's just natural science. The third component of science is the patterns of evolution. How does the tree of life branch through time? Interestingly enough, creationists accept natural selection and the other evolutionary mechanisms, but they reject the pattern of evolution because they believe in special creation, and they reject the big idea of common ancestry. Now, understood this way, evolution is an aspect of the natural world and thus suitable for science to explain. The history of the universe is a function of matter, energy, and time, thus science. And in fact, standard Christian theology views it as such. There's a very famous geneticist named Theodosius Dobzhansky back in the 1970s wrote an article that starts, "Nothing in biology makes sense except in the light of evolution." Now, this is I had trouble taking this picture because this is about a 5.5-foot tile. It's a really, really big, I shouldn't go too far away because this man's trying to film me. This is a really big tile on the floor of a new science department in a large Midwestern university. Each of the science departments were allowed to design their own big tile as a way of communicating to students and others who visited the science building, what is their science all about? Well, the biology department chose this statement of Theodosius Dobzhansky to underscore the fact that in biology, evolution is the concept of common ancestry is the glue that holds all of the observations of biology together. Everything is like it is in biology because living things have common ancestors. You know where this is? Notre Dame. And in fact, Catholic theology has been quite consistent about the acceptance of evolution. The Catholic theologian Jack Haught has been quoted as saying, "Nothing in theology makes sense except in the light of evolution." Statements of religious organizations in NCSE's book, Voices for Evolution, which you can find online, contains a section from religious organizations making it clear that their theology accepts that God created, but that evolution was the means by which God created, a theological view known as theistic evolution. Now, clearly, there are Christian views that are not compatible with evolution. Those who believe the Bible is literally true, and especially that Christian salvation depends on the book of Genesis, evolution is not going to be accommodated to their faith. But evolution is not inherently anti-religious. Empirically, many Christians have made peace with evolution and, in fact, find that it enhances their faith. So there are many choices to be made if you are a Christian about evolution and your faith. So considering all of this, what should we teach in schools? No question there are people who object to the teaching of evolution, and there continues to be a struggle to get evolution taught in public schools. Yet evolution is critically important scientific concept for students to understand. It's an aspect of the natural world, so it is a suitable subject for science class. It should be taught, and it should be taught as it is understood by scientists, not with qualifications like teaching the weaknesses of evolution along with it. Go and ask your biology professors to give you a list of the weaknesses of evolution. They'll look at you like, what? There isn't a list of weaknesses of evolution. purely a creationist invention. The meaning of evolution, on the other hand, is a matter for a student's religious or philosophical view. Because students should be religiously neutral, teachers should neither promote nor denigrate religion. Schools must be religiously neutral. This is from Answers in Genesis. He says, "Listen, kid, there is no real Adam and Eve, no forbidden fruit, no curse because of Adam's sin, which means there was no need for a Savior to come to earth to save us from our sin." In other words, and notice he's wearing a dark fish, on his shirt. In other words, the message from Answers in Genesis here is that evolution means you can't believe in God. Evolution means you have to take your religion and shove it. That's the point of view that's presented from this particular a religious perspective. This is the fear that a lot of conservative Christians have, that in addition to learning science, students are being taught to reject their faith. In my experience, this is vanishingly small at the kindergarten through 12th grade level. Empirically, kindergarten through 12th grade teachers have the same distribution of religion as Americans as a whole, which means they're about 85% Christian. So it's highly unlikely that there's this huge perspective out there in the K-12 classroom that's trying to demean conservative Christians' religious views. But this is the fear. This is a fear that they have. I believe it's an unrealized fear. I think it's much more common that students are being deprived of learning evolution because of anticipated pushback from parents, administrators, or students. Now, the Nobel laureate Steven Weinberg said, "I personally feel that the teaching of modern science is corrosive of religious belief, and I'm all for that." Well, this seems to be the conservative Christian's greatest nightmare. But then he goes on to say, "But I don't think that attitude of mine should control the high school curriculum. My own personal motivation is irrelevant. Science should be taught not in order to support religion and not in order to destroy religion. Science should be taught simply by ignoring religion." And this is exactly how we should teach science. Students have a right to interpret the meaning of evolution for themselves according to their own theistic or non-theistic ideologies, but schools must teach good science, and that means teaching evolution. And teaching the nature of science, which is methodologically, not philosophically materialistic. Now, there's a lot more information about this at ncse.com. If you'd like, you can sign up for a free electronic newsletter that comes out every Friday that I think you will find full of depressing information. If you go to the news page here, you will find, those of you looking for term paper topics, you'll find a lot of information. You can sort by year or by state to find out more about creationism and evolution controversy. You notice the sort of, that doesn't show too well on this slide, there's sort of a yellow climate section there. We've just started adding resources in climate science. And obviously, we're a membership organization. We're delighted to have you join us. We have a website. You saw the website. We have a YouTube site. We have a Facebook page. And I also have a Facebook page. Thank you so much for inviting me to be part of this.